For over a century, the atom was pictured as a nucleus surrounded by a continuous cloud of electron probability, suspended in an empty void. Gibsonian physics treats this smooth, continuous model as an interface-level shadow, a simplified projection of a much more precise underlying reality. The limits of this continuous model appear in the screening problem of helium. When standard math calculates the distance between two electrons, it underestimates the binding force because it assumes any coordinate in the void is possible. This discrepancy suggests that continuous math is accounting for ghost directions, paths between particles that the underlying hardware does not actually support. To reach a precise measurement, the smooth void must be replaced by a discrete, countable traffic network. Understanding atomic stability requires a shift in accounting. We have to stop measuring vague distances and start counting the exact microstates available to a particle on that network. The universe's foundational hardware is a rigid tetrahedral grid of S units. Every point has exactly 4 connective ports leading to its neighbors. Particles cannot exist in the gaps. They must actively hop from port to persist without stalling. In a one-proton basin, a single electron forms the simplest stable, unbroken loop, an order 2 closure. This loop tracks a specific radius, arriving at the same scale as the Bohr radius by following a rigid, token-mediated path. Because the path is segmented, the electron has exactly 137 subluminal speed slots available to it at this radius. Hydrogen is a single-lane track, locked into the rigid architecture of the grid. Adding a second electron creates a traffic problem. 2 particles must now share the same grid space without colliding and stalling the atom. One of 4 ports is permanently committed to anchoring with shell to the nucleus. This leaves exactly 3 ports available for movement. The grid also imposes a 3-step update rhythm. Combining these 3 ports with the 3-step rhythm creates exactly 9 relationship states between the 2 electrons. Occupying the same local slot simultaneously causes a collision. Out of 9 possible states, exactly 1 is a collision. This leaves 8 out of the 9 angular and spin paths safe for the electrons to occupy. The total screening law is found by multiplying the grid's baseline burden, 3/8, by the radial and angular safe paths. This yields a fraction of exactly 8/27. Atomic stability is the result of particles navigating a microscopic needle of safe, countable paths. This 8/27 fraction is a physical law that can be verified against observed chemical data. When applied to helium-like ions, such as lithium+ and beryllium-2+, this exact fraction predicts the ionization energy states across the entire sequence. As nuclear compression increases in heavier elements, the prediction becomes even more accurate, confirming the grid's underlying geometry. This structural predictability replaces the vague approximations used in continuous wave models. Ultimately, the stability of matter is the direct outcome of particles navigating the universe's strict 4-port architecture.